Hello, myself Sujithra Nair, Assistant Professor, Department of Electronics and Communication System. Here I am going to discuss about the subject virtual instrumentation. So here we are going to know what is virtual instrumentation and its advantages and their architecture of virtual instrumentation. So first we are moving to definition. So a virtual instrumentation. A virtual instrumentation is a system software that is used to develop and measurement and a computerized test system for controlling an external measurement hardware devices. It is supported by LabVIEW programs. The LabVIEW programs are called as virtual instrumentations or VIs because their appearance and operation intimate physical instruments such as oscilloscope and multimeters. It consists of two windows. First is block diagram window and second is front panel window. The block diagram window holds the graphical sources code of LabVIEWs. It consists of three basic blocks: terminals, nodes, and wires. Terminals are the entry and exit ports that exchange information between front panel and block diagram. The terminals are analogs to parameters and constant in text-based programming languages. The control and indicator terminals belong to front panel controls and indicators. Next, nodes. A node is just a fancy word for a program execution element. Nodes are analogous to statements, operations, functions, and subroutines in a standard program language. LabVIEW has a special nodes called formula nodes that are used for mathematical expressions. Next, wires. Wires connecting nodes are terminal hold a LabVIEW together. Wires are the data path between source and destination terminals that deliver the message from the source part to destination part. Next, we are saying about advantages of VI. The VI performance is high. Next, it is a platform independent nature, and next the flexibility is also high. The lower cost in plug-in and network hardware, reducing system specification time. The hardware and software costs are also low. Next, we are moving to architecture of virtual instrumentation. It consists of mainly 6 parts. First one, sensor module, sensor interface, information system interface, processing module, database interface, user interface. Next, we are going to look about the architecture of virtual instrumentation. A virtual instrumentation is composed of following blocks, that is sensor module, sensor interface, information system interface, processing module, database interface, and user interface. So, first, sensor module. The sensor module detects physical signal and transform it into electrical form and transform it into digital form for further manipulation, that which signals sends the physical signals from the source. The next is processing module. Integration of the general purpose microprocessor or microcontrollers allow the processing module. That the signals sent by the sensor module is processed in the processing module. It is of two kinds. First one is analytical processing and second is artificial intelligence techniques. The artificial intelligence techniques, it's a technology could be used to enhance and improve the efficiency and capability and features of the VI instrumentations. Next, the analytical functions. It defines clear functional relations among the input parameters. So, some of the common analysis used in virtual instrumentations include spectral analysis, filtering, windowing, transform, peak detection, or curve filtering. Next, the database interface. The database interface in computerized instrumentation allows measured data be stored for off-time processing or keep as a records. Next, database management systems, commonly known as DBMS systems. They provide efficient management of data and standardized insertion, update and deletion and selection of the data we provide. Next, information system interface. A virtual instruments are increasingly integrated with other medical information systems such as hospital and information system. They can hold or create executive dashboards supporting decision support, real-time alerts, etc. So next we are going to look about the conclusion of virtual instrumentation. Virtual instrumentation achieved mainstream adoption by providing a new model for building measurement and automation system. The virtual instrumentation is a system software that is used for user to develop a computerized test and measurement system. LabVIEW programs are also called as virtual instruments because the appearance and operation intimate physical instruments such as oscilloscope and multimeters. It has front panel window and block diagram window. The front panel objects appears as terminals on the block diagram window, and block diagram objects include terminal, sub-BIs, functions, constant, and etc. LabVIEW also has special nodes called formula nodes. It is used for the mathematical expressions. The wires and the terminals are the main part of the block diagram window.